Okay, let's finish up section 3.4 now, the slope of the line. We have a couple of applications to look at. Number 3A. When the roadside service truck is called, the cost of the service is given by this function. Y equals 2x plus 60, where y is in dollars, right? And x is the number of hours the car is worked on. X equals number of hours of work. Okay, how long they have to get it connected up and tow it or whatever. Service it. Find the intercept and slope and find and interpret the intercept and slope of the linear equation. Okay, so if this is going to tell us how much we owe, then we're going to be paying $2 multiplied by every hour of work. Is that hour of work? That's hard to believe, isn't it? Yes. And then the 60 must be a flat fee. If they come out to serve you at all, it's going to be like a flat fee. So let's interpret this. This is the slope. The slope is 2. And what it means is there is a $2 increase per hour. For every hour, it's sloped, so it goes up like $2 each time, like if you were graphing it, and time went across the horizontal. Every time you went over an hour, the cost would go up $2, okay? Now, they also want us to interpret the intercept. The y-intercept is 60, so 0, 60. So that means at time 0, you already owe $60. So that means there is a minimum charge, minimum initial charge, right, of $60. That's a flat charge. You pay $60 if they bring out the help. Then you pay $2 an hour after that. Okay, so that is how this works. And we'll move on to 3B. Similar question. The amount of water in a leaky jug is given by the linear function y equals 117 minus 10x, where y is in ounces, and x is in minutes. So this is a jug and it's leaking. It must be starting out with this, right? And it's leaking 10, what? Well, it must be ounces. 10 ounces every minute. That's the way this is going to work. So we'll begin with a slope, and we could rewrite this if you wanted to as y equals negative 10x plus 117. That would be fine. The slope is negative 10. This means it's leaking out, right? It has a loss of 10 ounces per what? Per x, and per x is minutes. 10 ounces per minute is being lost. That's what the slope means interpretation-wise. Okay, then the y-intercept. The y-intercept is 117. And what that means is that we start with 117 ounces in the jug. That's what we start this problem with before the leaking begins. And every minute after that, we lose 10. All right, good. Okay, let's move on to the next type question. These are testing the special cases. Sorry, that's a 4. 4A says find the slope of this line, x equals 3. We think about the graph of that. If you made a table, remember that back to primitive graphing, we make x3 everywhere, and y can be anything. So what we have is something that goes over 3 always, and then y can be anything. We have a vertical line at x equals 3. And they want us to tell what the slope is. On a vertical line, the slope is undefined. Okay, and let's see what happens if you don't notice this and on the test and you say this is 3, 0, and 3, 4, and we're going to test those using the slope formula. So this is my x1, my x2, y1, and y2. We think of these as points and we calculate the slope. y2 minus y1 will be 4 minus 0. x2 minus x1 will be 3 minus 3, and so I get 4 over 0, and remember, you can't divide by 0, so we see that this is undefined. So you have 2 ways you can do it. You can create your own points, you can draw the graph, recognizing it as a vertical line with undefined slope. Okay, and now we will go to the second example of these, 4b. And it says x is equal, no, sorry, it says x minus 5 equals 0. Okay, and I would like to put the 5 on the other side and say this is the same as x equals 5. Okay, where does x equal 5? This is almost exactly what we just did, isn't it? X and y. X is 5, y can be anything. So we go over here 5, and the vertical line will be at x equals 5. So once again, we have a vertical line. We can test the points, but the slope is going to be undefined. Okay, and again, you could calculate this x1, x2, y1, y2. The slope is 2 minus 0 over 5 minus 5, which gives me 2 over 0, which is undefined. Okay, so that's what we're always going to get with a vertical line. Okay, example 4c. And that says y equals negative 4. All right, if you think of this as a table and let y be negative 4, x can be anything. And we can calculate this, or we can graph it, either one. I'm going to think first of graphing it. If I graph this line, and I go to 0, 4, right here, and 1, 4, you can see that we're going to have a horizontal line. And we've gone over that before. Horizontal lines are flat. They have no slope. The slope is 0. We call it slope 0. Okay, so the slope equals 0 on this. But let's go ahead and calculate it. This is our x1, x2. So this is the point x1, y1, and that's the point x2, y2. So I use my slope formula, and I take y2 minus y1 minus a negative 4, right? All over x2 minus x1. So this is a negative 4 plus a 4 over 1. Negative 4 plus a 4 is a 0 over 1, which is a big fat 0, right? It's okay. You take your calculator and test it. 0 divided by 1 is 0. But the other way around, 1 divided by 0 would be undefined. So this has slope 0. We've done it 2 different ways, and you're welcome to do either one that works for you, okay? And finally, we need to talk about lines that are parallel or perpendicular. All right, so let's define these terms again. Parallel lines have the same slope. Okay, that's the first case. Parallel lines are lines that never cross. They run along at the same slope forever. So they have the same slope. So if we want to know if they have the same slope, we see what the slopes are, and if they're the same, they're parallel, right? Okay, so the other cases perpendicular lines. Perpendicular lines are two lines that form a right angle together against each other, right? They make a 90-degree angle. That's a right angle. Perpendicular lines. The slope of one of the lines is the negative reciprocal of the other. So if the slope of one line is 2/3, then the perpendicular line will have a slope of -3/2. So it has to be the negative, and it has to be the reciprocal. Let's do a couple more examples here. If we have a line that has slope -5, okay, then the perpendicular will be the negative of that. So we make it negative, and so that's the negative part. Now we do the reciprocal of this. This is a 5 over an invisible 1. So its reciprocal is 1 over -5, which makes it a +1/5. So if this has a negative slope, the perpendicular line has a positive. They're always the opposite sign, positive and negative, and reciprocal. Flip them over. Okay, let's do one more example of those. If I have a slope of -1/3, a perpendicular line would be the opposite of that. It would be a positive, and it would be the reciprocal, 3/1. So you have to do two things: change the sign and invert it. Okay, so those would be perpendicular to each other, 3 and -1/3. Okay, so that's how that goes, and we need to now try some problems like that. And we'll be doing more of these as we learn more about lines. This would be example 5A. You are to determine whether each pair of lines would be parallel, perpendicular, or neither. Okay, so if they don't have either of those special relationships, we say neither parallel or perpendicular. 3x minus 4 and 3x plus 2. These are in the handy form slope-intercept, which allows us to know what the slope is. And I'm going to do this. I'm going to say the slope 1 for this first line is 3. I can tell that because this is in the mx plus b form, right? And this is also in the mx plus b. So the slope of the second line is also 3. Those are the same. These lines are parallel. The symbol for parallel is like this. Okay? Sometimes you'll see it that way, and sometimes just parallel like that. Okay? So I'll show you both, and we will see how this book uses a symbol. I don't know for sure. Okay, let's do another example and determine whether the lines are parallel, perpendicular, or neither one. -2x plus 4y equals 1, and 6x plus 3y equals 2. Oops, 3 equals 3. Let me make sure I copied that right, since I had two problems writing it down there. Good. So let's take each of these lines individually and look at it and get it in the form y equals mx plus b. So I'm going to leave the 4y over here, subtract, get rid of the -2x by adding 2x. Okay? And divide by 4. 2 over 4 and 1 over 4. So this has a slope of 1/2 x. Okay? That's the first line. Now I'm going to take this line over to here, and I'm going to solve it for y. And then I'm going to compare these slopes that are sitting in front of the x's in the slope-intercept form. Okay, so I'm going to bring the 6x over by subtracting 6x. So I have 3y equals -6x. Notice I always put the x's first to get it into that slope-intercept form, plus 3. Now I'm going to divide the 3 off. Divide by 3. Divide by 3. 2x plus 1. Okay, now remember the slope is the number sitting in front here. We have a slope of 1/2. Line 1 has a slope of 1/2, and line 2 has a slope of -2. Notice that these are opposite signs, and they're reciprocals because this is a 2 over an invisible 1. So these lines are perpendicular. Okay, and the symbol for perpendicular is this, always, okay? Why are they perpendicular? Because these are opposite signs and reciprocals. That makes them perpendicular lines. If you could graph them, if you weren't sure, graph these lines and verify that, but it will work out that way. Okay, one more example of this type, and we will be done with this section. 5C. Determine whether these lines are parallel, perpendicular, or neither. So nice when they give it to you in this form, because we can easily see that the first line has a slope of 3. And the second line, it's in the mx plus b form, we'll call that m1, right? m2, the second line slope, 2 just designates the second line, has a slope of -3. These are opposite, which might make me think they were perpendicular, but they are not reciprocals. Okay, they're the same number, but they're not the same sign. So these are neither parallel nor perpendicular. And all you have to write is neither. Okay, that will be sufficient. All right, that concludes 3.4, and I will see you back for the next section soon.